Hello everyone. Today we are going to see some more examples for the grammar. Okay, so this is the third type of grammar. We already saw how to write a grammar for the given statement by drawing the DFA. Later we saw how to derive a grammar by checking with a regular expression. So now this is third type. They'll give a question like this. That is a language. Okay. So what this language says, language is equal to a to the power of n and b to the power of n such that n is always greater than or equal to 0. So here what happened, we need to consider three cases. First one is a to the power of n, means n can be any number. Okay, n can be any number, and what they're saying, a to the power of n, b to the power of n means first it should have a to the power of n, then b to the power of n, means a should be followed by the b. For example, you can have a to the power of 2 means then it should be b to the power of 2. Okay, and such that they are given a condition, that is n can be greater than or equal to 0. Greater than or equal to 0 means it can have a to the power of 0 and b to the power of 0. It means it can be epsilon. Okay, so we should write a grammar such that all these conditions are satisfying. Okay, so these are nothing but given data. Now we'll start the real answer. Okay, so what we'll do, we say like this, we'll write a grammar. S derives, so it starts with A and end with B. Okay, and in the middle we again put the starting symbol S, so that it can loop the same A as B. In the place of S, again I can substitute A as B. Okay, so that whenever we have one A, it will be always followed by the one B. Okay, and we want to stop it at one stage. After printing many A's and B's together, we want to stop the input, so that time we can take epsilon. Okay, so now these are the two productions we got it. Means one is the production that loops the A as B, and second production it says epsilon. Example, I'll just show you some example to confirm that it gives all the different type of strings as a output. For example, if you want 2 times A, means in the place of S we'll substitute A as B. Again in the place of S, again I'll substitute, keep the A as it is. In the place of S, again we'll substitute A as B. Already one A, B is there. So you can see 2A and 2B. In this place of this epsilon, we'll substitute epsilon. Okay, then we generated 2A, 2B. Means the number of A is equal to number of B. Means A to the power of n, B to the power of n. Okay, getting it? If we don't want anything, so sometimes it allowed epsilon also. Why? Because they're saying n is greater than or equal to 0. Okay, it is not only this part of the question, you should be very clear to this question also. Why? Because they're saying n greater than or equal to 0. So if it is 0 means S derives epsilon. Directly in the place of the starting symbol, you can substitute epsilon and get the string epsilon as a valid input for the given grammar. Okay, so now we got the production. Now we'll write the grammar, that is grammar is equal to VTPS. Okay, so in this one, what are the variables we have? We have only one variable, that is capital S. Okay, and what are the terminals we have? We have A comma B. Okay, and what are the productions we have? We write these two productions, that is S derives A as a B, comma second production S derives epsilon. Okay, this is the production, and yes is the start symbol. Okay, so this is the solution for the given question. Thank you for watching. Subscribe and like for more such videos.